First question states that you are given a particular code and you have to find the output of the following C code. So the code has a void main function that calls the function count of 3, and count function is declared globally that has certain statements in it, and the first statement in it is static int d equal to I. Now you must be very well aware of the keyword static. You must know that static variables preserve their value over function calls. That means this statement would be executed only when this count function is called for the very first time, and after that this statement would not be executed. The initialization of d would only take place once, and the previous value of d that was present at the end of the previous function call would be used if another call is made to the count function. So this will be very clear when we continue with this question. But yes, to do and find the correct output of the such questions, you need to be aware of the function and use of the keyword static. So let's get started. Initially, our control would transfer to void main and count would be called with the parameter value 3. So we make a call of count 3. This value would become the value of n. So n becomes 3 in this case. Okay, here in this call n is 3. Now since it is the first call of count, so this statement is executed, and d is a static variable which is initialized the value of 1. After this we print n and we print d. So what are the values that are printed? N, which is equal to 3, and d, which is equal to 1. So the box that I am making means that these values would be printed in this call. After this, the value of d is incremented. It is a post increment operator. So don't be confused that whether this value would be incremented now or afterwards, since there is no other expression here. So this value would be incremented here itself. So now the new value of d would become d equal to 2. Okay, so d becomes equal to 2 here, and then since n is greater than 1, yes, and value of n is 3, count would be called with value n minus 1. n minus 1 would be 2. So after this, control would transfer to the second call of count. The call would be made with the value n equal to 2. Alright, now in this case, since it is the second call, this statement would not be executed. There would not be a re-initialization of d. So only print statements would be executed and the further statements will be carried out. So value of n is equal to 2. So the value would be printed as 2, and the value of d is the previous value that was present. So in the previous call of count, the last updated value of d was 2. So here also d would be printed as 2. Alright, this is an important statement, and you need to know what is the value of d if it is a static variable. Now d is incremented. So the value of d becomes 3. If n is greater than 1, yes, n is 2, and we'll make another call to count function which is count of 1. In this call, the value of n is 1. Please see carefully that after when I am making such recursive calls, the previous call of the function is not yet complete, because there is this statement that would be executed after we return from the recursive call. Okay, so please don't miss such statements while you are executing. Now we are on the third call of count. Count of 1 means that we'll again directly print n. N is 1. So what would be printed? 1 would be printed, and the value of d, last updated value of d was 3. So 3 would be printed here. Okay. Now afterwards d is again incremented and the value of d comes out to be 4. If n is greater than 1, then count. The if statement only has a single statement, that is call of the function count, but here n is equal to 1, so we would not make another recursive call. We'll directly jump to the final print statement, which is print d. Now d would be printed and the value would be 4. Okay, so I'm making dotted arrows to tell the order in which the print statements would take place. This so that you know what sequence to choose. Okay. Now after this, after we have completed this call of count, we'll return back to the previous call and we would execute the last statement. Now please be very careful here. When you return back from count, value of d is changed in the third call of count. When you return back to the second call and you print the value of d, the value that would be printed would be the latest or the last updated value, which is again 4. Okay, so after this again d would be printed. This is the sequence of execution of print statements, and after the count of 2 is finished, the second call, recursive call, is finished, we would return control to the first recursive call, which would print d as 4 again, because this is the latest updated value. All right, so what is the sequence of the calls or the print statements that would be made? 3 1 2 2 1 3 4 4 4. So the option that matches is 3 1 2 2 1 3 4 4 4. Yes, it is the first option only. So this is the correct answer. In this question, there is nothing much to do except for maintaining the correct values of the static variable d. Alright, I hope you understood this. So let's move on to the second question now. The second question states that what will be the output of the following pseudocode when the parameters are passed by reference and dynamic scoping is assumed. This question makes use of two major concepts, which are dynamic scoping and pass by reference. Okay, I hope pass by reference is a clear concept to you all, but still I would tell you in short version. When we pass the parameters by reference, we basically pass their actual addresses, or we pass the values of the, we exactly pass the locations of these variables, and the called function that is using these variables, if it modifies these parameters, then the modified value would be reflected back. So if there is a function a that is passing two variables, say x and y, by reference to another function b, and b modifies the value of both x and y. So now when the call of b would be returned and a makes use of x and y, the values of x and y would be the changed values of b, that would be the changed values that were made by b. Okay, this is not so in the case of call by value. The values are not reflected back. Okay, and the second concept is dynamic scoping. Dynamic scoping basically tells us to look for a variable in the upward hierarchy. So basically, if you have a function and you have used a particular variable, but that variable is not defined in that function, or it is not allocated memory in that function, then you will go up in the hierarchy and see if the calling function that called this function has that particular variable defined in it. If the calling function has that variable and its value, then the called function would use this memory location of the variable and the value itself. Otherwise, we'll keep moving up in the hierarchy till we reach the global scope. So the the concept of dynamic scoping would be very clear in this question. Let's get started and see how both these concepts are being used here. So we'll start with void main. There are three functions, n, m, and main. So please remember the values are, or the parameters are being passed by reference. So in void main, we call the function m of a, and it is a pseudocode. So it won't correspond to all the details corresponding to any particular language like C or C++. Okay. So m of a is called, here since a is not defined within main, so the concept of dynamic scoping is used. We look upward in the hierarchy since main function does not have a calling function, so we'll directly look upward in the global scope. In the global scope, a has been declared equal to 3, so m of a means m of 3 is being called. Okay, so the value of a is taken here from the global scope, which is equal to 3. Here a is not defined. Now when m of 3 is called, so basically y gets this value in this function. Y is assigned the value of 3. Then in the m function we have the first statement as a equal to 1. Now this is a definition of a. Definition of a allocates memory to a. So here a local variable is created inside the m function. So if in further statements a is being used and referenced, it will be the local variable a and its local value, not the global a, because the local variable with the same name hides the same variable with the in the outer scope having the same name. Okay, so m function defines a local variable, and now further inside m the value of a is being changed to y minus a. So here I'll write it down, y is equal to 3, which has been passed, and if since this value a is being passed by reference, so if any modifications are made, this would be reflected back. Okay, so y is equal to 3. This was the value originally a. Now the local a is equal to 1, and the value of local a is changed to y minus a, which is equal to 3 minus 1. Again I am using the local value of a, which is 1, and the new value of a becomes 2. Okay, now n of a is called. When n of a is called, the value of a is 2. This value is 2 because it is the local value that is assigned here and given to the function n of x. Now when n of a is 2, n of 2 is equivalent to n of x. That means x would be assigned the value of 2. Here parameter x is assigned the value of 2. Now inside n function we have a statement x equal to x into a. Now both these concepts are being used in this statement. So this is a very important statement here. When we are writing x equal to x into a, first of all, since the function n does not have the variable a defined inside it, so it will look for the calling function and find out if a was defined there. Alright, since a was defined there and the value of a was 2, so it will use the value of 2. Okay, and secondly, x currently has the value 2 again, which was passed to it. So the new value of x becomes 4. Now this new value will be reflected back here. So the value of a, the local a, now becomes equal to x. A becomes equal to x, which is equal to 4. So the local a now becomes equal to 4, and now print statement would be executed. What would be printed? 4 would be printed. Okay, here. But before doing all this, when x was assigned the value of x into a and we print x, here also 4 would be printed. Then the control would come back to the m function. Again print statement would be executed, 4 would be printed, and then we would return back to the main function. So this was all about this question and dynamic scoping. So the correct answer is 4, 4. In this question, dynamic scoping concept is very important. We basically did not do much. We passed the parameters by reference. All we did was that in the initial main function, since there was no a defined, we used the global a and its value, which is 3, So 3 was passed as a parameter by reference to function m. Now, since function m contains the definition of another variable with the same name as a, so this a is the local variable of m. In this case, we modify a and pass it to the function n. We modify a to the new value of 2 and n is passed the same value of 2. X gets the value 2 here and we modify the value of x as 4. Since x is modified, so this change would be reflected back in this m function because the parameters were passed by reference and the changed value is printed. So that's all for today's lecture. These both questions had few tricky concepts in it, but if you do them carefully, you can easily get the correct answers and grab marks in your papers. Question reads as, consider the following function implemented in C. Void printx y, int of x and y are parameters. Inside we declare a pointer, then assign x to 0, assign the pointer to the variable, the address of x, assign the value of the pointer where it is pointing to y, and then change the data of the pointer to 1 and then print x and y. So we have to tell what will be the output of this function when it is called or invoked with parameters x and y. So initially when it is invoked with parameters x and y equal to 1 each, x is 1 and y is 1. Initially this is 1 and this is 1. Inside the function we are declaring a pointer and this pointer will be pointing to x here. That means we declare a pointer ptr and there is a variable x which is initially containing value 1. X is then changed to value 0. That means this becomes 0. The value becomes 0. Then pointer is assigned the address of x. So the pointer is referencing x. Then y is assigned data of the pointer. That means the value of y will now become the value of x because star of ptr means the data of the location or the address where ptr is pointing, and ptr is pointing to x, so now y also becomes 0. Now star of ptr becomes 1. That means x again becomes 1. Here again we'll change the value. These are the same things. I'm just showing this diagrammatically and these are the exact values. So and after star ptr is assigned 1, we printf the results. So here x is 1, y is 0. So the answer is C 1, 0. So it was a very easy question. You just need to know what is a pointer, how it is how it references and dereferences a value, all right, or how we use pointer to assign it a particular address of a variable and retrieve the value that is stored in that variable to which the pointer is pointing. Now let's come to the second question. The second question states that in the C program there is a string or a character array which is pointed by C, and this array is gate CSIT 2017. There is another pointer, character pointer, which is again assigned the value of C. That means if I draw this array as this GATE CSIT 2017 and I assign the index to these. Alright, so initially C is pointing to the starting location of this character array, then P is also pointing to this location as well. That means the starting address of this array, and now we have to print the string length of this expression. Now what does C plus 2 of P minus 6 of P minus 1 mean? When we say 2 of P, that it is exactly similar to writing star of P plus 2 or star of 2 plus P. That means we are referencing the second index of the pth array, character array. That means if P is pointing here, we are referring to the second index, which is T here. Alright, and similarly 6 of P. 6 of P is equal to star of 6 plus P, which is equal to P of 6, sixth index of P, and here sixth index means character I. Alright, so this is character T, this is character I. Alright, now solving the further expression, C plus character T minus character I minus 1. Now C is the pointer to the starting of the array. T minus I means we are basically subtracting two characters, and when we subtract two characters, we actually subtract their ASCII values. So you don't have to be afraid that even you don't exactly remember what are the ASCII values of T and I or different alphabets. In case of subtraction, you can just count the letters between these two characters and get the result. So if we start counting from I, after I, T is the 11th alphabet that you'll happen to see. That means after I, if you count J, K, L, M, N, N, O, P, Q, R, S, T. So it will come out to be that the difference between the two is 11. So no matter what is their ASCII value, the value will come out to be, or the expression will be reduced to C plus 10. Now what does C plus 10 mean? C is pointing to the 0th index. C plus 10 will point to this index, C plus 10. This was P of 2, this was P of 6, and this is C plus 10. Alright, and now we have to find out string length of C plus 10. C plus 10 is actually this string, the string 17. So 17 is a string of length 2. Therefore, the answer of this question would be 2. So it is a little tricky, but if you know that what does this representation say, how do you subtract the characters when the characters are given to you in an expression, and what does actually addition of an integer value to the starting address of an array mean, this value, then it is not very difficult to find out. So you have to be thorough with your concepts, the basic concepts of C programming or pointers and character arrays. Alright, so that was all for today's lecture. If you like the video, please share it with your friends. Subscribe to the channel of Easy Engineering Classes to get more notifications on the upcoming videos, and tell us in the comments below how did you find the video. Thank you for watching. Stay tuned and hit the bell icon to get more notifications.